numbers.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
find the rational numbers between two numbers using mean method. Examine the irrational numbers. Represent the irrational numbers on a number line. Explain the real numbers. Represent the real numbers on a number line. Evaluate the operations on real numbers. Know how to rationalize the denominator. List the laws of exponents for real numbers. Explain the concept of surds.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
In previous classes, we learnt about natural numbers. These are the positive integers from 1, 2, 3 and so on. It is denoted by n. Whole numbers. The whole number is a number that has no fractional part like 0, 1, 2 and so on. It is denoted by W. Integers. It is the collection of negative numbers and whole numbers like -2, -1, 0 and so on. It is denoted by Z. Rational numbers. A rational number is one that can be represented as the ratio of two integers like -2, -1, -5/3 and so on, where denominator is not equal to 0. It is denoted by Q. Do you know how to find rational numbers between two numbers using mean method and how to represent irrational numbers on a number line? And do you know how to rationalize the denominator? Here, in this chapter, let us know how to represent rational and irrational numbers on a number line, and also about rationalizing the denominators and different types of laws of exponents for real numbers. Representation of whole numbers on a number line. To represent whole numbers on a number line, initially mark the point 0 on the line. Then, by setting equal distances, the right side of 0, we plot numbers like 1, 2, 3 and so on. Representation of integers on a number line. The integers number line is the same as representation of whole numbers on a number line, but here, to the left side of 0, the negative integers like -1, -2, -3 and so on are plotted. Now, let us learn about representation of a rational number on a number line. For example, let us consider the number 10/2. Here P is equal to 10 and Q is equal to 2, where P and Q are integers and Q not equal to 0. Here the number 10/2 can also be represented as 5/1. Similarly, let us consider one more example, that is 16/24. Further simplification is as shown on the screen. So all these are equivalent rational numbers. Thus, from examples 1 and 2, we conclude that the rational numbers do not have a unique representation in the form P/Q. And also we observe that the rational number of the form P/Q, assuming Q not equal to 0, and that P and Q doesn't have common factors other than universal factor 1. So, on a number line, among all the infinitely many fractions equivalent to the given number, we use simplest form to represent all of them. In the given fraction 2 is the numerator and 3 is the denominator. From image 1, let's see the pictorial representation of 2 by 3. It means that from 3 equal parts, 2 parts are taken out as shown in the below image. Representation of 2 by 3 on a number line is as shown in image 2. Let us represent 2 by 3 on a number line. Initially draw a line. Take a point O on it and mark it as 0. From the right side of point O, set off equal distances to A, that is OA. Now divide OA into 3 equal parts as denominator is 3. Let OP be the segment consisting 2 parts out of 3. Thus, the point P represents the rational number 2 by 3. And similarly, for representation of rational number minus 2 by 3, set off equal distance to the left side of O, that is OB. And then divide OB into 3 parts. The segment OP' consists 2 parts out of 3. Thus, the point P' represents the rational number minus 2 by 3. Let us do a simple activity on rational numbers. Choose the appropriate answer whether it is right or wrong. 1. Is every integer a rational number? Yes. Every integer is a rational number, since they can be represented in the form P by Q. For example, let us consider minus 4, which can also be rewritten as minus 4 equal to minus 16 by 4, which is a rational number. 2. Is 0 a rational number? Yes. 0 is also a rational number, as it can be expressed as 0 by 1, 0 by 2, and so on. Say 0 by infinity is equal to 0, where infinity not equal to 0. 3. Does rational numbers have unique representation? No. The rational numbers do not have a unique representation in the form of P by Q. For example, 16 by 4 can be written as shown. Let us discuss how to find the rational numbers between any two numbers using mean method. Mean method is categorized into 2 types, namely method 1 and method 2. Click each method tab to know more. Method 1. If P and Q are 2 rational numbers, then its mean is P plus Q by 2. Let us consider the two numbers 2 and 3. Here P is equal to 2 and Q is equal to 3. Then the mean of these two numbers is 5 by 2, which lies in between 2 and 3. If further the process is continued, we obtain many more rational numbers in between 2 and 5 by 2 as shown below, where 2 is less than 9 by 4, less than 5 by 2, less than 3. Method 2. Let us consider the same numbers used in method 1. Here, to find 4 rational numbers between 2 and 3, we write 2 and 3 taking denominator as 4 plus 1 is equal to 5. That is, 2 equal to 10 by 5 and 3 equal to 15 by 5, which is further expressed as shown on screen. Note: thus, we conclude that there exists infinitely many number of rational numbers in between any two given rational numbers.